Hello, in this video we are going to review linear functions, and to do so we are going to solve a long exam question. The exam question is so long that we cannot even fit the question and the answers in the screen, so now you should stop your video and read through all the parts of the question from A to I. You may find that you get lost after a bit of just reading if you are not working at the same time, but just do it and well, we're gonna get back to each part and you will be fine. So what I'm going to do is to move out this second part so we have a little bit of space to work with. We begin by having 2 points and we are asked to write the equation of the line that goes through those points. We can write the equation in any form we like because it just says write the equation. We could say write an equation, that will be fine as well. So let's go and do it. Let's say we want to write it in the form y equals mx plus b. Then we know that m is going to be the slope or gradient, and then b is going to be the y-intercept. So let's find the slope. So for that we have a formula that says that we have to look at the difference between the y coordinates and divided by the differences between the x coordinates. So in this case, for the y coordinates, I'm going to say 3 minus -1. And then for the x coordinates, if I took the 3 first, I need to take the 0 first for the x. So it's going to be 0 minus -2. So this is 3 plus 1 over 2. So this is 4 over 2, which is 2. So the slope of my line is 2. So far we know that the line has equation y equals 2x plus b. We need to find what is the value of b. B is the y-intercept, and actually we were so lucky that over here we were given the y-intercept to begin with, because we were given that the point 0, 3 is a point of the line, so when x is equal to 0, y is equal to 3. So that means that the equation is y equals 2x plus 3. So we have our answer for part A, y is equal to 2x plus 3. If I were doing this in an exam, I will make sure that I didn't make any mistake by checking that the points verify the line, so that if x is equal to -2, then the result for y is -1, and if x is equal to 0, the result for y is equal to 3. I'm going to erase the work I did, not because it's not important. It's very important, and definitely in the exam you have to include it, just because I need to make space to keep going. So let's look at part B. Part B says, oh, this was the line L. Let me write the name over here as well. This was L. Part B says that there is a new line P that is perpendicular to L and goes through the point capital P. So the first thing I'm going to write is what is the slope for the new line. So slope, I'm going to call it MP. And because it's perpendicular to our original line L, the slope is going to be the negative of the reciprocal of the slope of our line. So -1 over 2. We found the line L has a slope 2, so a line perpendicular to it has a slope -1 over 2. So far we know that our line P has equation -1/2 x plus b, and we need to find the value of b. B is the y-intercept, but we do not know what is the y-intercept. We know that the point P is a point of the line, so that means that when x takes the value 3, then y has to take the value -1, because I have here the point P being 3, -1. So that means that -1 is the same as -1/2 times 3 plus b. And from here we can find the value of b. b is going to be -1 plus 3/2. So b is equal to 1/2. So now I can write what is the equation for my line P. It is y is equal to -1/2 x plus 1/2. And again, I'm gonna keep this result because we will need it later. I'll add it over here. But I'm gonna have to erase the work so I have enough space to keep going. Now we need to find the point of intersection of the two lines L and P. So we want a point that verifies at the same time that y is equal to 2x plus 3 and y is equal to -1/2 of x plus 1/2. So what we are saying here is, well, we're trying to solve a system of linear equations with two equations and two unknowns. And we have already y as isolated in each of the equations. So we are saying y is equal to blah and y is equal to blah blah. So blah and blah blah have to be equal. So 2x plus 3 has to be equal to -1/2 of x plus 1/2. We want to see for which value of x this is true. We have in this case denominator 2 for the two terms in the right hand side. So I'm going to multiply everything by 2 just to make my life easier. So I'm going to multiply the left hand side by 2 and the right hand side by 2. So we get that 2 multiplied by 2x, so 4x, plus 2 multiplied by 3, so plus 6, has to be the same as -x because the 2 and the half cancel, plus 1 because the 2 and the half cancel. This means that we want 5x to be equal to -5. I added x on each side and subtracted 6 on each side. So that means that our value of x is -1. So now we know that when x is equal to -1, we get the same value for y. So let's go ahead and find what is that value for y. So y is going to be, we can use any of the two equations. Y is going to be 2 times -1 plus 3. So this means that y is going to be -2 plus 3. So this means that y is equal to 1. Let's check that we will get the same result with the other equation. We should, so that means we are doing fine. So y is equal to -1/2 times -1 plus 1/2. So from here we have y is equal to, I'm multiplying negative times negative, that's positive, 1/2 times 1, that's 1/2, plus 1/2, which is 1. So we check that it was correct. So what we found is that for the value of x, -1, and the value of y, 1, that point is both in the line P and the line L. So this is the point of intersection that we call capital I. So let me write it over here so we keep it. Capital I is equal to -1, 1. And once again, I'm erasing our beautiful and very important work because we don't have space. Okay, I didn't include the axes that were part of the exam question, but we are just going to sketch the function anyways. I'm making some not too big axes over here so I can fit everything. This is x, this is y. I need to show the scale. I'm going to show that 1 squared corresponds to 1 in both the horizontal and vertical axis. And now I'm going to go ahead and sketch the lines and the points given. I'm going to begin by sketching the line L, and 2 points were given for that line, so I'm going to sketch those 2 points. One point had coordinates -2, -1, so this is the point over here, and the other has coordinates 0, 3, that was the y-intercept here. Those 2 points determine the line L, because any 2 points of a line determine the line. So that's enough for me to sketch my line L. Let's see, try to be precise with my ruler. It's harder than it looks, guys. Okay, I'm trying to not be too picky. I'm gonna say it's there. Almost. Yeah, sorry about that. I move it without wanting. Okay, again. Let's say it's there. It's not perfect. I'm sure you can do it better than me by hand. So this is the line L. I'll write over there. And let's use the sketch to check that our equation is correct. We say that the slope is 2, so let's check when we go from one point to the other. So from the point -2, -1, if I go one step to the right, I have to go 2 steps up. So 1 step to the right, 2 steps up. So that gives a slope of 2. So we're fine. And the y-intercept is what we want as well. So we're confident that we are doing a good job so far. Now I'm going to sketch the other line. The point 3, -1 is given. So let me add that point here, 3, -1. This is the point P. We were asked to include it as well. And now the line has to be perpendicular. It's hard to see perpendicular, but I'm going to use that we found the point of intersection. Well, actually not. Let's not use the point of intersection. Let's use the y-intercept at a half. So we can verify that the point of intersection is what we want. So let's now move the ruler to go through these 2 points, the point P and I need to be really careful. Yeah, there it goes. Both the point P and the y-intercept. There we go. So this is our line P, and we can see that actually, yes, the point of intersection is a -1, 1, and that's a point that we call I. Okay, the question continues. Let me scroll down to show you what were the remaining parts. This video is finishing here, but I want you to stop it and keep going on your own to try to solve parts E, F, G, H, and I. And of course, you will ask me if you have questions.